Good morning, everyone. I'm Steve.
And I am Scott.
And together we are Backyard Musings, broadcasting from Apple Valley, California.
Definitely the Science and Technology channel today. We are talking
definitely.
Pretty
neat.
Some interesting
Pretty
stuff.
interesting.
Yeah.
Skoltech scientists have devised an efficient method to extract hydrogen from natural gas fields while trapping carbon emissions underground, potentially revolutionizing clean energy production. Remember we talked about, I think it was back in January.
Hydrogen car bomb?
No, that was last year.
Oh.
Back in January, we talked about how they were trapping CO2 in the ground from these, I don't think it was oil wells. I'd have to go back to the notes and see. But we did a similar.
From fracking?
I
don't remember.
No.
We'll have to go back.
No, it doesn't. Yeah. But I remember that. The findings of the research were presented on 4th of May. May the 4th be with you, 2024, in the journal Fuel, and supported by a grant from the Russian Science Foundation. Would you like to know more?
Skoltech researchers have developed a method to produce hydrogen directly at the natural gas fields with an efficiency of 45%.
Doge needs to get over there.
Okay. The process involves ejecting steam and a catalyst into a gas well, followed by the addition of oxygen to initiate combustion.
That doesn't sound safe.
Yeah, it doesn't. This catalyst-assisted reaction generates a mixture of hydrogen and carbon monoxide from which hydrogen can be efficiently separated. The breakthrough offers a promising step toward large-scale hydrogen production at the source.
Okay, so we've got a slide here that shows the operation. I'm going to take a look at that. I'll embed us into it so you can get it bigger. Yeah, so you got the injection well, production well, and I guess you got to know how far apart to go, right? But it seems like you combust that it could and then sink back down.
They'd have a new well.
It just seems
that sounds
catastrophic.
Kind of dangerous.
I guess they must have tested it to see. Maybe that's why we're getting earthquakes in diverse places, I guess.
Well, and in California, which I don't know.
We had an earthquake.
We get them all the time.
Yeah, you made fun of it yesterday. You said, "Oh, San Diego."
Yeah, we had one in San Diego.
Yeah, I felt it.
Julian, which is a little north of San Diego, I guess.
I felt that it was a little. I told you it felt like a little hedgehog running underground, and the thing just went up. The ground.
So a long way from San Diego. So, but you never know.
No. All right. Today, around 80% of global energy comes from fossil fuels like oil and natural gas, which emit carbon dioxide when burned, contributing to climate change, probably crisis also, and environmental degradation. Although natural gas is often viewed as a cleaner fossil fuel due to lower emissions of toxic pollutants compared to oil, it still produces significant carbon dioxide.
In contrast, hydrogen fuel emits only water vapor during use, making it a cleaner alternative. However, challenges in the hydrogen production have limited its widespread adoption. Skoltech's new method could help overcome these barriers and accelerate the shift towards cleaner energy sources. So we like that.
Yeah. For the first time, a team from the Skolkovo Institute of Science and Technology in Moscow has proposed extracting hydrogen from the reservoirs of natural gas fields, and they got a lot of natural gas over there, which are rich in hydrocarbons that contain a large amount of hydrogen at the molecular level. This means that hydrocarbons, once converted, can yield an abundance of green fuel.
Okay. The team has proposed an efficient, multi-step process for producing hydrogen from gas fields. First, steam is injected into the well along with a catalyst that will later help separate hydrogen from the natural gas components. Then, air or pure oxygen is pumped into it to ignite the gas directly in the reservoir. Assisted by the steam and catalyst, the natural gas burns and is converted into a mixture of carbon monoxide and hydrogen.
I read what's going on here, but I can't picture it. The combustion underground. I see exactly what they're saying. I just can't follow it. It's blowing my mind.
Yeah.
The carbon dioxide formed from the carbon monoxide remains in the reservoir and does not contribute to the greenhouse effect. I gotta sneeze. Excuse me.
Wind.
Excuse me.
Right.
One more. That was two more. At the final stage, sorry about that, Scott.
Down.
Lucky
I'm
they were
down
cousins, man.
Great.
At the final stage, hydrogen is extracted from the well through a membrane that blocks other combustion products. Oh, okay, there we go. Leaving the carbon monoxide and carbon dioxide permanently trapped underground.
Bless you.
That's the last one.
The researchers tested their process in lab reactors that simulated a real gas reservoir environment. They placed crushed rock in the reactor and then pumped in methane, the main component of natural gas, along with steam and a catalyst, and then oxygen. The pressure inside the reactor was maintained at a level typical of gas reservoirs, 80 times higher than atmospheric pressure.
That's a lot of pressure. As the experiment progressed, the team analyzed the composition of the gases in the reactor to assess the efficiency of methane conversion into hydrogen. It turned out that most of the hydrogen, 45% of the total gas volume, was formed at 800 degrees Celsius. That's hot.
Yeah.
With large amounts of steam injected into the reactor. That reminds, that's like a volcanic explosion. Remember, we have that segment about the crystallized brain. Yeah. And that was like 600 Celsius. Yeah. Large amounts of steam injected in the reactor. To make the reaction as efficient as possible, there should be 4 times more steam than natural gas. Okay, 4 times. It's kind of exact, right? The researchers chose the 800 degrees Celsius temperature because it is easily achievable in natural gas combustion and does not need to be artificially maintained.
The hydrogen field also depended on the composition of the rock. For example, in experiments with porous alumina, the hydrogen yield reached 55%. The higher efficiency in this case is explained by the fact that alumina is inert. Example, it does not react with surrounding elements. Natural rock contains other, more active minerals that can react with the components of the gas mixture and affect the hydrogen field.
Quote, all the stages of the process are based on well-established technologies that have not previously been adapted for hydrogen production from real gas reservoirs. We have demonstrated that our approach can help convert hydrocarbons into green fuels in the field environment with an efficiency of up to 45%. In the future, we plan to test our method in real gas fields, says Elena Mukina, PhD, a senior research scientist at Skoltech Petroleum and the leader of the RSF-supported project. Okay, so let's test it out on the real deal. You know what I'm saying?
Sure.
They got this in the lab.
Yeah.
Hydrogen, I mean, we could do like the Hindenburg. It's highly combustible.
But as soon as they start having seismic activity, they're going to be shut down. So, I mean, that was one of the deals with fracking, right? In Pennsylvania and in, I think it was in South or North Dakota, where they started having seismic activity where they never had it before. I mean, don't get me wrong, I got nothing against fracking. I think it's a great method for extracting natural gas, right?
Yeah.
And we need natural gas for not only for selling it, but we're a high user of natural gas here, so
it heats our homes.
Yeah,
you can use it on barbecues.
Yeah. Some people tap into their natural gas lines and
heat the water in the water
instead
heaters.
Of using propane. Yeah. So, but yeah, sometimes the methods don't match the benefit
to the ends. Yeah.
Yeah. So
yeah,
can't have earthquakes. That's just
Although
we did get a early warning that one earthquake, or not, I guess not an early warning, but an early warning. What?
We did not.
Well, the one that was in San Diego. They blasted over my phone. It didn't blast over your phone.
Yeah, it did. Like seconds later, 10 seconds later.
Well, that's pretty early.
It's after, not early. It's later. A later
Leave us
warning.
your comments. Have a great day.
I don't want to hear comments about my sneezing either.
It's a natural act.